So today has been trouble everywhere. We had a hard time in lecture today, and it looks like this group is still rowdy. So sorry, you have a rowdy group.
I love rowdy groups.
That's good, that's good. So it is my honor to welcome Alice back to campus. This building wasn't here yet when she graduated in 2005 with a physics major. She's been all over the place. I just learned while she was a student, she did a semester in Chile as an REU student, which I had no idea, studying astrophysics. Sounds easy. That doesn't sound like a problem at all. She went to RIT for her PhD research, done all sorts of amazing things in between all of this stuff, and now she's the Chief Financial Officer for Nanotronics, a company that does a whole bunch of stuff using words that I don't understand. So Alice is going to, did you read what it said? I was like, I don't even know what, I can't even like read this. So Alice is going to talk to us more about what she's done and how she got there, I'm guessing.
Thank you.
All right.
Thank you. I guess I don't know if this is on.
Travis, is this thing on?
Yeah, it's on.
Okay. If you guys can't hear me, just let me know. Apparently, I was failing Jackie. Is one of the first rules of a scientist is that regardless of what you are doing, your ultimate goal is an educator of others. So I apologize to you for not being a good enough educator. Well, I want to thank you guys for inviting me here. This is kind of a fun thing. When Jackie reached out to me, I was like, that sounds awesome. And I just want to kind of poll the room. How many of you here are computer science majors? Okay. We got one over there in the corner. Oh, we got one over here. And how many of you are math majors? Okay, good, awesome. And how many of you here are biology majors?
Kind of, yeah.
Or chemistry? And what are the guys that didn't raise your hand, or what do you guys do? Health science. Oh, I didn't even think of that. Shame on me. That didn't exist when I was here.
Yeah, no, it didn't.
So,
that's a new one, yeah.
That's a new one. So.
We got physics, we got physics.
So I'm here to talk to you today about winning the game of manufacturing. And, you know, why is this important? Everything we touch is made. Everything from our shoes to the chips that are in our phones. Does anyone here know how semiconductor chips are made? You over there. That. That's actually really close. So when they're first made, it's actually grown from a grain of sand. And a lot of people don't realize that their phones were originally grains of sand. And then it takes everything in between to get there into your hands. And there's a lot of steps and a lot of problems that could happen in between.
And then when I get it, I break it.
And so let's see here if I can figure out how to work this thing.
I don't know how to make Jones do it.
So we're living at really interesting times. You know, there's things that are happening now that the world has never seen. We have a significant rising cost of technology, and you guys are probably seeing that just as equally as big companies. You know, things are costing more to buy. You know, everything ranging from a head of lettuce to your cell phones to your books that you're purchasing for your Kindle. Everything's increasing in price. Now, one of the major concerns that I think most of us here in the room is that global climate change is happening. There's a lot of different opinions about what that means, but the reality is that there is a climate change that's happening. And one of the things that really motivated me to the field that I'm currently in is I have a 6-year-old little boy. And after the pandemic, before I came to Nanotronics, I felt kind of hopeless of where the world was heading and what I could do for it. But I knew I wanted to make a better world for him. And my background from my family perspective is my family owned manufacturing facilities, everything ranging from optics to jewelry to everything in between. And it was something I grew up with and I learned about and I was very passionate about. And the reality is that when I looked at my son, I said, well, if everything was optimized at 100% efficiency, and what does that mean? Well, that means that there's no more waste being created by what you make, and there's the minimum amount of energy being used and the minimum amount of water being consumed. The world will be a better place. And I started to envision a world for the first time that gave me hope that I might be able to leave a world in a better place than I've come into it. And this is a really big thing to consider, because as we're using these things like ChatGPT, the amount of energy that these computer models are going to be using is going to be more than the entire humanity uses for our everyday lives in 10 years if technology does not change. Now, this is a really scary thought. And we're in a position here, you as students, you are going to be helping create and change that future if you can approach these problems differently. I was talking to Jackie, and I said there was a couple of really important moments that happened here to me at Wells College. And one of them was the procrastinator that I am. I did not have an internship by summer. I waited till like May to find an internship. And, you know, the career resources, I don't know who it was, they called, told me that I should make phone calls in areas that I wanted to learn about. I was like, okay. So I started cold calling. I don't know if this is, even though I wasn't emailing, I was actually picking up the phone and calling, being like, so do you have an internship? And I was thinking about places of where I wanted to go and what I wanted to do with my life. At the time, I thought I wanted to be pre-med, and I decided that that was just not was meant for me. So I was like, well, I like Star Trek, I like science, I like space. I was like, I like the Museum of Natural History. I live in New York. So I called the Museum of Natural History. I picked up the phone and I called. And I got Neil deGrasse Tyson on the phone. And he said to me, hi, well, we just started a new internship program. I don't have any money, but if you could come, we'll be more than happy to teach you. So I was like, well, it costs me $20 a week to get there. I was like, so I'll have to go to my dad and ask if I can, you know, if he can give me the money so I can get there. He said, okay, well, you get back to me, and there will be a spot for you if you're willing to learn. So I went to my father. I said, well, can you give me a Metro card so I can get up there and have this internship? And he said yes to me. And then when I was there with these students, it was one of the most pivotal periods of my time of life. One of the things that it taught me was not only astrophysics was something that I was really passionate about, but what it more importantly said to me is that there's large problems. And when you think about the concept of the universe, these are problems so large, and people dare to think that they can solve them. You know, and they're thinking differently than everyone else. You know, before Einstein's theory of relativity, people said this couldn't be done. And when you go through your life, whether it's a professor or a boss or a colleague or a friend or a customer, they're going to tell you this can't be done. And it shows you that if you think the same way as everyone else, then it can't be done. And problems of the future will not be solved with this mindset. And this kind of leads into my next big thing, which is we're living in a time of geopolitical uncertainty. And this can't be ignored. And I'm not here to talk about politics, but I will talk about political implications that is going to have on our everyday lives. One of the biggest issues that is happening right now is as the world becomes more and more fragmented, there's a bifurcation. And a bifurcation means a splitting of mindsets and technology. What mine is mine, what's yours is yours. And what's really kind of frightening of this is that we're living in we have been taught as scientists that it is important to collaborate and approach problems as a community. And one of the things when I was here at Wells that later came of this internship that I had in the Museum of Natural History is that I was working at Princeton. Every day, like here at Wells, they would, at 2 o'clock, we would meet for tea. And we would discuss problems. And it didn't matter if you were an undergraduate student or the head of the astrophysics program there at Princeton, we would bring problems and we would talk about them and communicate and how these problems can be solved. Now, with these geopolitical uncertainties, this is happening less and less. And more importantly, there's what is known as corporate espionage. When you become more split as countries, that means you are no longer doing business in those countries. So what the problem with that is that there's no consequences for you stealing technology. If you have technology in China and I'm working in China, then it makes me less likely to steal Chinese technology because I can have my factory confiscated, or vice versa. And these are real world consequences of not being able to split. And it's ultimately going to slow down new generations of technology of not having this sharing. So semiconductors, it's supposed to be one of the most advanced manufacturing platforms in the world. They use cutting edge technology. There's all these things that it's using, but one of the things that it does not use is artificial intelligence to any sort of sophistication. And that's kind of hard to believe when you think about all the things that you're hearing right now. And starting in 2015, there was an executive summit of the top CEOs in the semiconductor industry, and they publicly said that they do not believe artificial intelligence is or can ever be usable in the semiconductor manufacturing space. Now think about that. Just think about where that wasn't that long ago. That's less than a decade ago where they're saying, and there was early generations of AI that was happening at this point. And with these early iterations of AI, the first game of AlphaGo beat the first human in chess. I mean, not chess, Go. Does anyone know familiar with AlphaGo? Okay, a few people here. Good. Now, some people might be asking, well, how is Go relevant to what you're talking about? Well, the thing about Go is that it's a very confined space. So you have a board, there's so many pieces, there's rules, and there's an objective. In this case, the objective's winning. And what AlphaGo did, which was was kind of a paradigm shift in how to approach problems, is it wasn't optimizing for winning by the most amount of pieces, by winning the fastest, by taking the most pieces from your opponent. It was just by winning. That was the only metric of success. And what it discovered and what it showed to us as scientists and to people that actually could put this into practice was that it made decisions that statistically humans could make, but in reality humans would not make. And it made a move in, I think, the third or fourth game that 1 in 43,000 humans could make. So think about that. 1 in 43,000 humans would have made that move. And during that move, it ended up losing close to 50% of the pieces on the board. But at the end of the game, it won by 1 point. And why is this important? Because it shows that sometimes humans just don't have the ability to make the connection between the cause and effect. And what we see in manufacturing every single day is that when scientists, especially in industries like biologic manufacturing or semiconductor manufacturing, where these people that are working in the manufacturing facilities, and they're highly skilled PhD material scientists, engineers, they've gone to school for probably 20 to 30 years to become as skilled as they are in these fields. If they don't understand the cause and effect, they will not change their process. And what that means to us as consumers, it causes delays with us and causes increased pricing in us getting those goods. Because if a factory goes down for a day, week, a month, 6 months, and these PhDs are trying to diagnose what the problem is, that's a delay for us getting the technology. And let's put it even closer to home. What if that was your mother who was sick? What if it took doctors a year to diagnose that problem? These are things that we are not able to do as humans in the time that is needed to make a real powerful impact. And this is where artificial intelligence is so important. Who here knows Moore's Law? Okay, we got a couple people. So Moore's Law was, so Moore is the founder of Intel, and he came, when he was pitching his investors and the potential people to invest into Intel, he said technology would double in speed every 2 years. And the actually less known law is actually Rock's Law. And Rock's Law was Moore's first investor. And he said, well, I know technology is going to increase every 2 years, but I think the costs are also going to double every 2 years. And what that means for us is we're really right now with technology, if the way we make technology does not change, we are at a point where it's too costly to invent new technology. So this is where we are as, as mathematicians, as material scientists, as chemists and physicists. Like, this is where it's really important, because in health science, it doesn't matter. Whatever you are touching to deliver your services or product to your person, if it's too expensive, then it eliminates a massive group of people that do not have access to it. And one of the things that artificial can help do is, ironically enough, the answer to this is really to improve artificial intelligence to solve some of these problems that us as humans can't actually solve ourselves. And if you guys have any questions or want anything, just let me know.
Now you got a hand up.
Oh, hand up, yes.
I was going to ask, I guess, like, given that Moore's law kind of tapers off over time, is there like, how does that interact with Rock's law? Like,
So,
assuming Moore's law is tapering off, because it seems to be.
so Moore's law is tapering off because Rock's law has surpassed it. So the theory is that if the problem of Rock's law is solved, if we can solve and reduce the cost of technology, Moore's law would continue as it currently is, new technology doubling. And there's also a lot of problems with the semiconductor space, with the cost of building the buildings, the clean room space, which is a big area barrier for both biologic manufacturing and semiconductor manufacturing, is that these things, bringing it to market is so expensive. The average cost of a drug is usually close to $1 billion and takes 20 years of development. Someone has to pay for that at some point. And this is just something hard to do.
I was going to ask if you had any examples of like things that have kind of been too expensive to do, because I actually not really interesting.
I would say, you could say semiconductor chips manufacturing right now is a perfect example of that.
I mean, like, what specific processes or changes?
Well, I'm going to get to that.
Okay.
So we're right now in the age of generative AI. Now, I know seems everyone was kind of hit by a wave with ChatGPT. They were like, wow, this is a newfangled thing. But the thing about ChatGPT is that generative AI has been around for quite some time. It's really started with AlphaGo. And one of the big things about what is generative AI, that's the ability for a computer to make decisions based on information that it has. So I'm going to kind of go into details about this. Now, generative AI is rapidly impacting our lives, everything from how you guys are producing work to how the IRS is evaluating who's paying their taxes. These are all things, but in my opinion, the most impactful thing that artificial intelligence could be used for is to bring more things to the world with less materials. I want to make more stuff with less stuff. And this is where I think the true power of generative AI can have. In that case, it will impact everything we're doing. It will help bring down these costs to us, and it will help allow us provide better futures for ourselves and for our families. But did you know that there's really not one place that we're not seeing AI at all right now? And I kind of briefly gave you a sneak peek about this earlier. And that is in industrial applications. Now, I'm not going to go into the really nitty-gritty on what it means to do statistical process control and all these other fandango things, but I will kind of go into the history of how the stuff we use is made and how the mindset behind it, because it's very much like being a scientist. It was originally the first type of manufacturing quality control was introduced in the early 1900s. Now you're looking at every time you go to a chemistry lab or in any sort of physics experiment, what's the highest quality product that you can bring to your process. Now, one of the things with quality control is that the more you do, sometimes it increases the cost because you actually have to destroy stuff you're making to see if it's good or bad. Now, the next thing is statistical process control. This was actually brought to the world after World War II when we're rebuilding Germany's industrial infrastructure. And with this, it was looking at, by Bell Labs, what they looked at the whole system. So you have a whole system, and what I consider a factory, there's a lot of different steps. And what they do is they look at each step individually and try to keep them within certain conditions and upwards and lower bounds, hoping that the best yield will happen. And then there's a statistical evaluation to try to get that as narrow as possible. But there's things that doesn't take into considerations. Humans are one of those considerations it definitely doesn't take into account. Also, it has a really hard time taking into real-time effects such as weather, humidity, power consumption, all of these types of things that can impact your process. And then with that, we kind of went farther in being able to use an actual statistical model, which is called the Dumbing model, to kind of more automate this process. But until then, until the invention of generative AI with the paper "Attention is all you need," the real first access to using artificial intelligence in the manufacturing process didn't happen until a few years ago, roughly 2019. So that was really recently. So manufacturing and infrastructure management really hasn't been changed in close to 100 years, if you really think about it, and how we approach these problems. Now, these are all the newfangled words that you hear about all the time. Some of you may or may not know what they do, and that's kind of what I want to explain to you, because it's important to understand what the differences are and why it's important to you in what you're doing. And it's even more important to kind of understand, as you're looking for what you're doing in the future, all of these things are based on what's happening in a vector matrix in math. So one of the things that Jackie and I were talking about is, I was never a good mathematician. I was never a really good programmer, which is probably why I went into astrophysics, observational astrophysics. But, these are the things that mathematics is really important, because this is what is backing up how these models are working. And if you don't have a basic understanding of how it's working in the background, you're not going to be able to implement that in a real world scenario. Everything ranging from, someone making tires to, how a building HVAC system is working, to a ventilator that's supporting someone in the hospital. So computer vision was probably one of the earliest forms. It's not technically AI, but it's one of the early predecessors to AI, and that's using, like it sounds, using a computer to see things. And humans are tagging what they're seeing to identify that. So when it runs the models, then later on, and this is called supervised learning. Now, all of you here have been tasked with this at one point or another of your lives, and you're probably not even aware of this. If you've ever clicked on it in the computer, "I am not a robot," and then you select the images, "Oh, this is a car," you are helping someone tag their models unwittingly. And these are things that are being done on a regular basis, and this is really important because it's being used for everything from identifying cancer cells in a human, to identifying manufacturing defects. In this particular case, these are defects that are on a semiconductor chip wafer, to everything in between that's happening. And there's something that's also really important about this, because with the tagging process, you do have to be aware that it is as biased as the person that's tagging it. And this is something that is known as AI bias. And this is something I feel very passionately about, because it can affect everyone, ranging from who's getting parking tickets to who's going to be offered the next level of their job applying to a new business. So these are things that affect every single day of our lives, and we have to be really conscious of how we're doing this. So natural language processing. This is what everyone here, I'm sure, is intimately familiar with, but doesn't know that's what it's actually called. This is what ChatGPT is using. And what it's doing, this particular case, is how it's applicable to manufacturing. But with ChatGPT, it's scanning the entire space of the internet and then some. so this is the amount of data that is consuming is vast. Now with manufacturing, quite often you're going in and you only have 700 megabytes or 500 megabytes. So the difference and the robustness that the models need to have, and the models are what are actually doing this analysis, need to be actually significantly more complex. And here we have one of the things growing up in a manufacturing household is that you always have these people that we call machine whisperers. And you might see it in what you're doing, that student over there that's doing something better and they can't quite identify what they're doing. You ask them to explain it to you and they're like, I don't know. This is just what I'm doing. And what we're using here is that we have a particular part, and the quality wasn't that good. And we had one particular assembler that was consistently had the best quality, and he couldn't tell what he was doing. So, as he was going through the process, we were able to identify that one of the parts that he was receiving, even though it was the same part number and the same piece from the manufacturer, it had a little X on it. Sounds crazy, right? Well, this X, if it was put into our machines, had 100% rate of failure. And something in his body, his soul, was able to identify that from happening. And I've seen this hundreds of times over. I'm in a manufacturing facility in India. There's some guy that hears a noise and he knows that's when he should put in the catalyst into the reactor. These are things that are happening, and these are feelings that people get, but it's based in real time reality of what we recognize as humans, even though we can't identify. In that particular case, it's probably the vibrations or the sound that he's identifying. And these are where AI could really come in and identify that so it could be applied across the whole process to every single person. One of the things that Amazon did to try to increase productivity is that it did a stop-go. What ended up happening is they had a bunch of angry people when they went past the go and got failed. What I feel what we should be doing is giving people the tools to succeed, not the tools for failure. And this way, artificial intelligence is assisting these people in doing their jobs better. How would you feel to be put in a class when you are at your peak productivity for the most difficult class? That would make sense. I just had coffee, I went and exercised, I'm ready to do differential equations right now. Oh, well, I'm tired and I drank too much last night. I was up to 3 in the morning. This is time for me to do underwater basket weaving. These are things that could be optimized based on what is the reality of life. Now, multimodal learning, I kind of talked about supervised learning, and there's two types of computer learning. One is, learning like a child is learning through observation. You watch your mom cooking and you see them burn themselves. Well, you know now that you shouldn't burn yourself. And that's the life lessons that you took. And quite often as you're becoming more skilled, when you're sitting in class, you're learning through this type of, this direct observation. And then the other is learning by doing. I burnt myself. Bad. So with multimodal learning, this is making suggestions based on things that it's observed. So it's observing here in this particular case. I don't know if I can make the video go, but anyway. So it's showing someone how to assemble a piece based on historical data that has come in. So as I'm building something or as I'm making something, it sees that I can make it faster. Well, why is I'm doing that? Well, I've done step A, B, and C, except I did it A, C, and B. And that made a better quality product faster. And it takes note, and then it applies that to let other people know that are doing this. And this is this type of learning. And one of the key importances about this is to make sure that it's done. We all talk about what is AI, is it going to rule the world? This is where it's really important to set in safety guidelines, because if someone is going, beyond those safety guidelines, this not only can mean dismemberment, but it can be death, if not a major catastrophe that is happening. So these are things that we try to keep in check of, but there's other ways to be learning. These are the models that you're seeing when you're asking it to generate a picture. So there's a lot of ways that this is being used in our lives. Oh, well, I'm having beautiful AI, generate a PowerPoint presentation for me. These are ways that it's being used in everyday life, but this is the way it's being used to create physical things that we're actually touching. So generative AI. The power of generative AI is that it's able to make decisions using these other things to not only can predict the problem will be happening. So when we heard this situation with AlphaGo, and you're like, well, how is that related to manufacturing? Just like a Go board, how there's a unique set of pieces, there's rules that are being achieved. Manufacturing is very similar. There's X amount of steps of the process. There's rules of which the temperature can't be above a certain temperature because otherwise it could blow the reactor. Oh, there's time when this can be done. There's all these rules that are happening, and that's what we call process control. And that can happen anything within the motor of your car to creating your semiconductor chips in your cell phone. So when we were actually doing these toy models, and this is part of the fun of learning how your theories work in reality. Sometimes it's not practical. If we were to go out and build a bunch of factories, we would have had to raise billions of dollars to do this. Instead, what we did is we tested our toy models on 3D printers. Now, how is a 3D printer like a factory? Well, it heats up, it moves. We actually bought the cheapest 3D printers on the market, so it had a lot of problems. And what we did is we had a human engineer create a part. And it was a little dog bone shaped part, nothing special about it. But it was actually, for a 3D printer, pretty hard to produce. And then what our main winning the game is we wanted it to be the strongest piece possible at the end. So it had two confines for this. Our game was to have the shape, like everything that's manufactured, usually shape is really important. And then it was to be, have the highest strength possible, which is also really important in other confines like, safety and these types of things that could be set in a real world situation. And what we discovered is that the AI was making decisions that probably no human would have made. Instead of printing 400 layers, it would sometimes print one layer that was equal to 30 layers. Or it would slow down to correct over a problem that was happening. And then we started to try to inject problems that were happening into it, because we're scientists. We want to see how we could break stuff. And with this, we started shaking the table. We started, adding debris and dust, stuff like that, to see if the AI agents could correct over it. And what we discovered was something really interesting, is that the AI agents would also be able to identify something that was what we called malicious was happening, so shaking the table, and it was able to correct over it. So if there was an attack happening to your facility, it was able to identify that as another defect that was happening to your system and letting people know, oh, this is a problem, you should go look at that, which this is becoming more and more important with the worlds, unfortunately, that we're living in. So how is this kind of relevant to our everyday lives? Who here thinks electric vehicles is kind of cool? I think most people here at least would love to have a Tesla or something like it. There are several problems with the auto industry and electric vehicles and electrification of the world. There's two major problems. One, there's a chip problem. They use something that's called compound semiconductors, and from the word compound, that means they're using two materials and putting it together. The first compound semiconductors were actually discovered in space. This is how challenging it is to develop these new materials. And with the invention of compound semiconductors, and I'm sure Dr. Bailey could go into more details, is something known as a wide bandgap material. Why is this important to all of us, and why do you care? Well, the wider the bandgap material, the better it is with power efficiency. The other major problem with the auto industry is batteries suck. Current batteries are awful. And there's a lot of problem and waste that's happening with this. So these are two major issues that are facing this industry that are monumental challenges from a science perspective to overcome. As you can see here, this is just the manufacturing flow of what it takes to get to get a battery to market. Lots of little steps, there's lots of stuff that could be happening, there's major issues with contamination, et cetera, et cetera. So some of the things that they have tried to do to increase that is that they've put controls in each part of the process. This is the statistical process control that I discussed earlier. Oh, this setting's out of here, this setting's out of range. The problem with us as humans is that when we get a lot of alarms, we tend to ignore them. So these are all problems that are happening. So each specific one has a quality metric that is set by someone. It may or may not be correct. And that is what the golden template is, the rule of thumb, the truth that everyone is to abide by in that process. So, and with this, going from statistical process control, it's looking at each step. When you're using generative AI, it looks at the system as a whole, as a living, breathing organism. So it doesn't matter, how would you, if your heart is failing, it doesn't matter how good your foot is doing. And this is how it looks at the factory. If you have a failing system that's 4 steps behind or that happened 3 months ago, you could have a catastrophic failure today. And if you're seeing that today, it is too late to change that system. And this is why it's so important for generative AI to really come into play. It is not only making changes to the system, but it can predict that this problem will happen. And think about the power of that. How many problems would have been solved? Colonial Pipeline. Are any of you familiar with Colonial Pipeline? It's one of the most catastrophic oil failures that happened. I'm going to do deep mines, deep well. So this was an oil leak that was happened by BP. And what they realized is when there was alarm setting, the leak had already been happening for 4 hours. So this is 4 hours of billions of gallons of oil that were going into our oceans. These are consequences we can't fix later. These are real-time consequences. But where artificial intelligence could have prevented this from happening is that it would see that there's a tank. There's fluid coming in, there's fluid coming out, but there's something wrong in the tank that doesn't make logical sense. Maybe someone should go check it out. It can't say why it's happening, but it can tell us as humans that even though all of your sensors are working just fine, there's some sort of abnormality that's happening in your tank that you should go check out now. And if someone had gone to check out that situation, they would have seen, oh my goodness, it's beginning to leak. There's less liquid in the tank. Why is this happening? And solve the problem. And there's a lot of situations like this that are happening on a daily basis that could be solved with this. I think it was last year, or maybe the year before, there was a major baby formula shortage. So hundreds of children, probably millions of children actually, didn't have access to food because there was massive contamination issues in the manufacturing of baby formula. So that was a contaminant that went in, and they had to remove all of the formula from the market because not only could they not identify what batches were contaminated, but they couldn't identify what caused it. And this is where artificial intelligence really can come in and say, well, there was this particle that was in this batch, go check it out. Or stop run so we could fix the problem. Oh, an O-ring is about to fail here. And this is where the power is coming in to be able to affect our real-time, everyday lives of how we can improve our lives based on these types of observations. So I kind of want to end it here and leave some room for some questions. With artificial intelligence, where it is today, is probably, I would say, one of the largest technological advances from the internet, but I think socially, it's going to be the largest cultural change probably since the invention of electricity. Now, it will change everything we do. And I won't say that jobs won't go away, but jobs will change. And the future of work will change. And that is your job as students to be able to kind of see where it's changing to. And that's a really hard goal. I don't know if I have an answer for you guys on that one. But, the reality is what you can do is be prepared for it, and be willing to learn from others' mistakes. When I'm looking at hiring at people, I always ask people, well, what was the worst experience you've ever had? What's the worst mistake you ever made in a professional setting? And what happened? And what did you do about it? What did you learn? And these are things, because if mistakes are made and they're not learned from, then there's no way that you could prevent them from happening in the future. And this is where artificial intelligence is actually helping those mistakes being made, prevent them being made in the first place. So, okay, any questions, comments, concerns? Very chatty group. Well, thank you guys. Oh.
I was gonna say, usually, yes.
I was gonna ask, you're talking about like the generative AI and like predicting all of the parts of the process. I was like wondering, I guess I'm questioning generated here because I just
So
wanted to generate.
So it's generating decisions on how to change each set point in the system. So what the current system does is it has a control system, and it will change the temperature or the flow or whatever that system is doing because it's going out of alignment. What generative AI could do is say, well, the yields are going out of alignment, so all of these things should be changed because it will give you the most statistically the most optimal outcome. And that becomes more and more refined as the system is being repeatedly used. So for high volume stuff that's manufactured, let's say, toilet paper, that's being, millions of pieces are being made every day, it will be able to learn more quickly on what problems could arise versus something that's very slow to be manufactured and those steps take longer. It takes a longer time to learn where the problems may arise.
Manufacturing process is going to reduce waste, climate impact, etc. But also, all these AI programs and use require a lot of processors, processing time, and energy, and resources, and we've got Rock's Law. There's a circle here that we're kind of locked into. Do you see that changing? Do you see enough AI use being able to produce answers to fix the problems so the AI doesn't overburden our systems?
I think it's going to take longer than we need to, is the unfortunate truth of that. And there's several reasons for that. What you see traditionally with technological development is that it's a cycle between software and hardware. So software speeds up, and then it's waiting for hardware to get faster. And that's kind of like what's happening right now. Is software has exploded in its capabilities, and it's waiting for hardware to catch up. And part of this explosion was from the advent of edge technology and edge computing to be able to allow for these models to run as quickly as they are, and NVIDIA is the most famous for doing this well. But now it needs to be done again. Also, another major problem for that is, especially in the United States, most of this technology is funded by venture capital. It is a way better business model to invest into software because it's cheaper. It's cheaper to run, there's less costs associated with it, and that's kind of where the problem is here. Now, how that problem's being approached in countries like China is the government is investing trillions of dollars into closing that gap. Which the United States is trying to do right now with stuff like the CHIPS Act and stuff like that. I think it could be more, but it's a tough problem to address. Also, software engineers get paid probably 10 times what a hardware engineer gets paid, and these are things that I think are really large barriers to closing those gaps of being able to develop those technology. And generally speaking, developing new materials is really challenging. Like I said before, the first compound semiconductors were discovered in space. These aren't resources that the average day college student has access to. So you're not hearing about dorm room discoveries of new materials for the most part.
I hope not, right? or the ones that you are discovering aren't good.
How was the material discovered in space?
It was through NASA. They were experimenting to try to find new materials that were more electric conductive. So they could find silicon and carbide, carbon.
Were there reactions done in space? Or?
Yeah, they do testing in space. There's some interesting companies that all they do now is testing new materials in space. Another barrier on a philosophical mindset now that I think needs to be addressed is that if something new is invented through generative AI, you can't patent it. This is a really big problem as well that I think will limit the growth of some of these things. So if you invent a new drug using AI or design a new semiconductor chip, you know, the people that designed the models to do that can't be credited, and nor can the new design be patented, which that's a really big problem. So it's, all of this legislation is still catching up and trying to figure out what to do, and I think it's harming what the industry can do to solve some of these problems.
We're starting to hear some ethical issues related to generative AI, you know, gathering data from all over the place, and creating false narratives. You know, there was a legal case recently, you know, basically a specious legal argument drawn from some place while there was misinformation of it. How do you build in guardrails into the system such that, you know, AI doesn't recognize that the problem in this process is the humans involved? Let's destroy the humans.
So I would say in manufacturing infrastructure, it's significantly easier because there's certain things that are just dangerous to do. If you put like I said, if you put the temperature too high, the reactor will explode, and then we'll no longer have, you know, the city left. These are things that are easier to set. But when it comes to social constraints, you know, there's different companies that are trying to approach these various problems because it's too difficult to be able to identify the data because it's so vast. So what current industry leaders like Meta, as an example, Google, Amazon, all of these types of, you know, usual suspects, what they have done is that they have guide rails that are set, and then it tags something, and if the computer senses it as iffy, it's then sent to a human to check. But this is something I feel pretty passionately about. When your models are all written by the same type of person with the same thought process, and this is thought diversity. If they're all written by the same person that went to Wells College, they're all going to think similarly because they were trained a similar way. This is why it's really important when you're building a product to have people that are of different races and different socioeconomic backgrounds, from different educational backgrounds, because they're bringing in their unique perspective to the situation and identifying things that they would find repulsive to them, which might not be repulsive to someone else, and this is where it's really key to have those different perspectives. And this is why I think the bifurcation of technology is one of the things that could really limit the growth, because you're not going to have those various views that are going to be able to have that input into it.
All right, well, I think we should probably let everybody want to talk at the end, but thank you for coming, Alice.
No problem.
Awesome. I wanted to hear the second story, but I didn't want to. Can I grab some photos? You sure can. All right. You're ready for your photo op, right?
Oh.